We start with the theme of vector space which we began last time. Vector space and then vector subspace, it's quite meaningful, not means from, if you just say from exam point of view, one can have some kind of practice and all that in the standard method, but to get a total overview, to get an insight, it requires some kind of thinking. So last time we were talking about 3D space, 3 variables, Cartesian coordinates and equations of various entities in 3D space. As the subject is linear algebra, none of the variables is permitted to have its higher degree. It is either it is of having 0 degree, that is doesn't exist, or first degree. Means either there can be an equation can be in x, y and z, or one of them may be missing. But x square, y square and all that is not permitted. Then the very simple way to describe that is what is vector space and vector subspace. I am trying my level best. To what extent you are able to understand or not, that depends upon your interest and how much time you spend on thinking on it. So, you know, set and subset is somewhat like that to a large extent. A plane, when I have got a plane, I can say that infinite lines exist in that plane as well as infinite lines are not existing in that plane. There are few lines which may intersect the plane only in one point, whereas there are few lines, again infinite, which will intersect the plane, which will never intersect the plane, skew lines. Then the line means plane is a space, and line in that plane is its subspace. Plane is a space and a line means, when we say space, it is collection, means collection of infinite points. Plane contains infinite points. Collection of such infinite points which satisfy some condition. Plane. Then line, in which, so plane is in a way vector space. Then a line lying in that plane, is its subspace, means it is collection of those selected points on the given plane which satisfy, means for plane there is one condition, x, y, means we are having 3 variables x, y and z. When we put one condition, when there is no condition, means x can be anything, y can be anything, z can be anything, it is entire 3D space. We are constrained, not able to think beyond 3D. So no equations, no conditions means entire 3D space. the moment at which you put one condition, and that too being linear algebra subject, we are having a condition, some imposition, one equation you can specify. One equation you can specify. That equation may contain something x plus something y plus something z should be some other thing. Are you getting me? Something x plus something y plus something z should be some other thing. So in general, ax plus by plus cz is equal to d. Ax, because this is very important, and in coordinate geometry, since we learn coordinate geometry at maybe at late high school stage or at 11th standard, in 2D we are somewhat expert in it, but when we expand it for 3D, we are not so much curious, therefore many things are missed out between 2D and 3D. So ax plus by plus cz plus d is one condition which you have put on variables, and that one condition carves out a plane. Anna, very important, I am trying my level best. Suppose if that there is, when one will say why you put x, y, z, then there can be x, y, z, w. Only thing is that in Euclidean space you will not be able to visualize that. But theoretically, x, y, z, w, then there may be many more. X, y, z, w. Actually, then since it is 3, it was known. Remember again, see, if we go for number 3, why 12 hours are there? Why 12 hours are there? There are many logics. We are having 1 to 12, then 13, 14, 15. So up to 12, there are distinct words for numbers. Even though decimal number system is there, up to 12 there are distinct numbers. 12 has nothing to do about 1 and 2. 11 has nothing to do over 1 and 1. But 13, 14, 15, 10 and 3, 10 and 4, 16 like that. So a 12 has got, means it has got its own significance. Like that, when coordinate says x, y and z, then you start with x, y, that x and y. Then you add z. So you, then what about fourth dimension? Then you use w. Just to indicate that when it was started, that time for the Euclidean space thinkers, it was known that only x, y and z can be there. So they start with, ideally it should have started with z and y. Or if you want to start from beginning, a and b. But see how we should think very finely. We are using the alphabet at the end. X, y and z. If in 2D we use x, y, not y, z. Otherwise it should have been z, y and then x, then w, then v and like that. But 3D was known, x, y and z were defined, z is assumed 0, we work in 2D space, then we add z. Then if we allow w again, in that case what will happen? So it would be a 4-dimensional vector space. If we add v, it will be 5-dimensional vector space. So point, 0-dimensional vector space, fixed point, no degree of freedom. Point, given point. Given point is also 0-dimensional vector space. Then a line, if it is either matching with x, y or z axis, it is what we can say very spatial vector space. identity vector space, but it can be anything. So point, line, then plane. If it is xy plane, it is more convenient, but it can be any other plane. So fixed point, fixed line, fixed plane, but fixed volume we can't see. Why? This is very careful. This is what is expected by the students who study linear algebra. Fixed point, fixed line, when I say fixed point, I have selected only one out of infinite combinations. There are infinite points. I have selected one fixed. A line, I have selected a set of infinite points out of a total set of infinite points. Then a line includes many things which the point was not including. Then a plane. Again I have selected infinite points out of total infinite points. So plane contains something which the line was not containing. But because of the limitation of Euclidean geometry, point, line, given point, given line, given plane, but given volume, why? Because what is beyond a volume, is very difficult to visualize. It's not impossible. When we go in matrix thing, we can go by any dimensional matrix. But this is something which we must be aware. Therefore, Ax plus By plus Cz plus D is one condition which is put. So, if entire volume is a 3D vector space, actually it is frame of reference. In my frame of reference, entire volume. It is said that overall universe and what I see from my perspective, that may be different. Everybody may see different things from their own perspective. Like that, the case is for volume. Means volume is very important. Volume हा सर्वव्यापी आहे. मग त्याच्या पलीकडचं काय? Point limitations we see, line limitations we see, plane limitations we see. Means when I have a point, I can see that everything, there are many things which are not in that point. When I see a line, I see many things which are not on the part of the line. When I see plane, many things which are not part of the plane. But when I say volume, I don't see anything which is not part of that volume. Because of 3 being a limiting factor for my visualization. 3 dimensions. Beyond that I can't. So I hope that you should think in a way wherein you should be able to visualize beyond that. So here so entire volume is a 3-dimensional vector space. Of that, when I put one condition, any combination of x, y and z which fulfills this will be a plane. Is it clear? Any combination of x, y and z such that it fulfills this equation is a plane. If I make it simple, x plus y plus z is equal to 0. What kind of plane it would be? X plus y plus z will be equal to 0. What plane you can visualize? In fact, there is a huge scope for animation for linear algebra, unfolding the concept of linear algebra. There is a huge scope for education technology and animations. So x plus y plus z equal to 0. So what kind of plane you visualize? Certainly origin will be part of that plane. origin will be part of that plane. Then how the plane will look like? X plus y equal to 0 is what? A line. So how that line goes? X plus y equal to 0. It is in is like this. It is like this. X plus y equal to 0. Now x plus y plus z equal to 0. How it will look like? At z equal to 0. At z equal to 0, what happen? At z equal to 0, when z is 0, we must have x plus y equal to 0. So this line is part of this plane, and then
these same lines, set of lines along the z-axis.
like this. No. बघा एवढं लिनियर अल्जेब्रा बाकी काय आकडेमोड घेतली तेवढं ते महत्त्वाचं नाही आहे. आपल्याला काही कळतं का नाही? इज इट क्लियर? सो वेदर it will plane like this? No, because so this is their axis. This is your axis like this. So it is like this. What happens when I am on positive z? Both x and y negative. So they shall, when I move on in this direction, z will be positive. Z is positive. When I move on this direction, z is positive. So x and y should cancel that. So it should be like this. So this is a plane. This is a plane. So plane is a subspace of volume. Everything in the given plane is already there in the volume, entire volume. Means plane doesn't contain anything which is not part of the volume. Right? One condition. Now, if you further impose another condition, means this and something. Are you getting me? This and something. Then you further narrow down. So what you can impose? Is it clear? So in a 3D space, when we are having entire volume, no condition, all volume, no condition means, listen very carefully, what is volume? Volume is locus of all such points where there is no condition specified. काय कळलं पाहिजे. व्हॉल्यूम म्हणजे काय, गिवन स्पेस म्हणजे काय, 3D व्हॉल्यूम म्हणजे काय, तर अशा सगळ्या पॉइंट्सचा समूह की जिथं कुठलीही कंडिशन स्पेसिफाय केलेली नाही. हे संपूर्ण स्पेस म्हणजे व्हॉल्यूम. बरोबर? व्हॉल्यूम इज दिस. then a plane is locus of all such points where one condition is put on x, y and z in a linear manner. Otherwise 3D curves are not. If we go for non-linear algebra, then some conditions and 3D curves are there. So one condition on linear combination of x, y and z, ax plus by plus cz equal to d, is one condition. When one condition is put, we come down to a plane. Then no condition, volume. You put one condition. Then what is next? Instead of 1 you put now A, B and C and D. What we should have? A, B and C not all 0. If all 0 then condition will disappear. A, B and C are real numbers, not all 0 simultaneously. So in that case, if only 1 is there, these become simple planes, identity planes. If only B and C are 0, what will happen? If B and C are 0, what the condition would be? X equal to 0. So what is x equal to 0? This is x-axis, x, y and z. So x equal to 0 means this plane, right? This plane. Y equal to 0, xz plane, and z equal to 0, xy, right? So then x plus y equal to 0, x plus y equal to 0, this. Clear? Like that, x plus z equal to 0 means we get the the planes which are very much identity planes or very much specific planes if some are zeros. It's either there would be only one variable, x equal to 2, what it would be? X equal to 2, not necessarily 0, x equal to 2. It is a parallel plane, it's a plane parallel to yz plane intersecting at x equal to 2, like this. Is it okay? So these are different variations. Now, so one condition is put, a plane. Then when other condition is put, what is possibility? When one condition is put, it is a plane. Then while putting other condition, what अच्छा लगा? There are three variables. When no condition, anyone can take any value. There are 3 degrees of freedom. Means what? You can choose any x, you can choose any y, you can choose any z. No condition. When there is one condition, there are 2 degrees of freedom. What does it mean? In a plane, 2 degrees of freedom is what? Hello, what are you doing? Watch here. 2 degrees of freedom is what? We are having how many variables? X, y and z. So I have got 2 degrees of freedom means you are free to choose 2 and remaining will be given to you by the equation. Remaining, but now I make a statement, I put something deliberately wrong, you correct me. When there is one condition, one equation is there for a plane, I say that I can choose only 2 variables, remaining would be given by the equation. Am I right? Or some correction is needed? When I put a condition, I have got one equation in terms of x, y and z, one linear equation in terms of x, y and z. Then it's a plane. I say that plane has got 2 degrees of freedom. Means you can choose any 2 variables, but your freedom ends there. The third will be automatically given to you. You don't have that freedom if you are in a plane. So I use the word, you can choose any 2 variables and remaining will be given by the equation. Am I correct? Then what?
You can choose any values of the given 2 variables. Instead, 2 variables should be specified.
No, here x plus y plus z equal to 0. If x is 3, y is 2, z would be minus 5. X is 7, y is 9, z is minus 16. X is 0, y is 0, z is 0. So you can take any value of x and y. In this case you can. But if then what is x plus y equal to 0? Is it a plane? Yes or no? It's a plane. Which plane? X plus y equal to 0 is this plane. Right? It's this plane. Then what can you do? So x plus y equal to 0. So you can choose z. No. Can you choose z? Yes. Can you choose x? Yes. Y is given to you. Can you choose x? Yes. Can you choose now y? Here, try to get it. It's very specific, but you must be able to get the idea. Here, you can choose x, you can choose y, remaining will be given to you by the equation. But here, you can choose z, any z. You can choose any y, x will be given by the equation. You can choose any z, you can choose any x, y will be given by the equation. But you can't choose any x and any y. Because in the equation z term is not there. So, or this is a general case, a special case, and another one is z equal to 0. What is z equal to 0? It is xy plane. So there, can you choose z? No, you can't choose z because z is by default 0. But x and y you can choose. So a plane is that subspace where the user can choose two variables. He has got 2 degrees of freedom, but not any two he wants. But he can choose 2, maybe z equal to 0. He can choose any x and any y, no condition. Z is fixed. Here he can choose x and z or y and z. Remaining will be given. Is it clear? So there is a choice of deciding the values of 2 variables. Not any 2, but certainly some 2. Not any. Is it clear? Some 2 variables can be chosen. That would be a plane. This is one condition. Then no condition, volume, one condition we come to plane. One more condition will do what? One more condition. One more condition means there was no condition. I put one equation. How many variables are there? 3 variables. If I design one more equation, then one more equation which I can design can be either consistent with the first equation or inconsistent. So if first equation x plus y plus z equal to 0, or if I take first equation simple equation z equal to 0, and I say that second equation what I would take as z equal to 1. What is z equal to 0? Z equal to 0 is xy plane. Oh sorry, xy plane. And z equal to 1 is parallel plane to xy plane. Right? So when I put second condition, the second 3 variables, I can use one equation. Having one equation means one condition is already put. So it has resulted into a plane. Then I can put one more condition which can either be simultaneously true with first condition, consistent equations, or inconsistent with it. If inconsistent, I will get another plane and both can't be satisfied simultaneously. So 2 equations will either lead to impossible conditions which can be met together, will lead to 2 planes, or if not, then another plane. Suppose if I have got x equal to 0 is one plane and y equal to 0 other plane, what will happen? X equal to 0, y equal to 0. X equal to 0 is yz plane, and y equal to 0 is x equal to yz plane, and y equal to 0 is xz plane. So their cross section is z axis. X equal to, on z axis always x is 0 and y is 0, right? So x equal to 0 is a plane, y equal to 0 other plane, and both together give me z axis. So equation of z axis is two equations. So two equations lead to a line. Equal is enough. Any query?
X plus y equal to 0 when we say
Here.
this equation.
Ah.
So this equation can be created like the coefficient of z can be 0, z itself can be 0.
This equation.
This equation can be created by making the coefficient of z 0 or making z itself 0. Means if the coefficient of z is 0, then there is no restriction on z. And if z is itself 0, then
If z is 0, then z equal to 0 is another equation. So if you say z equal to 0, then x plus y equal to 0 and z equal to 0 will lead to this line. And in general, when you are having this as a1x plus b1y plus c1z is equal to d1, and a2x plus b2y plus c2z is equal to d2. Then these are two general planes, and these two together represent, this is also satisfied by a plane, this is satisfied by another plane, which is not inconsistent with the previous plane, then the intersection is a line. So two equations in 3D space, one equation represents a plane, 2 degrees of freedom, no equation represent the entire volume, 3 degrees of freedom, one equation represents a plane, 2 degrees of freedom, two equations represent a line. Means in line what you are supposed to do? There are two equations, so you can choose x and you can choose y. Can you do that? No. If you choose x, what will happen? That x and this would be another constant. It will go the other side. So you get two equations, b1y plus c1z plus b2y plus c2z. So both x and y will be given, y and z will be given to you. So in a line you have got 1 degree of freedom, remaining 2 will be given by the equations. And then when you add one more plane, other plane, so there in this is line, and one more plane is a point, no equation. So three planes intersect in a point. So x equal to 0, y equal to 0, z equal to 0 are yz, xz and xy planes. They intersect in origin.